See? So I try. Oh, sorry. Okay, so here's two paste clients. Okay, so first of all, revamp some of the Juxta stuff so now it is a little bit more reliable in finding everything and getting the events back. So if I do something like create a group and we will launch from okay, so that should load up an app. You'll see that it creates it, starts setting up its pipes, and it's polling for the for stuff that happens. So now if you look over here, it's shown up in the other app, in the other client, right? So I can join that. So I'll join, and then you'll see over here that it loads its app, right? It is going to go and it's going to look, found the other guy's pipe that he set up, right? So what I can do now is hit start, and that will open a little window over here. Okay, Steven, hello. I can send it. So what that ended up doing was it was caught by the other app, which popped up its own window. Okay, you'll see that it's doubling. It's getting multiple messages because I don't have any filtering on there. Since Juxta's pipes are best effort, it'll send it out a few times. And so what you need to do is filter based on previous messages, either through timestamp or something like that. You'd want to see if you already got something. So then, hello. See, so that'll go back. So you'll see, so it goes back and forth, and it's all passing through this these pipes. Okay. Now the main reason I put this app together is because I was trying to figure out how we're going to do basically marshalling and unmarshalling. When you send something over the network, you send it as a stream. The other side has to instantiate it somehow. Now the big problem I was running into with that is the fact that when you get something from the network, okay, how we have our app, the Juxta subsystem is actually not in the same kind of context as the application that you're running. So parameter sweep or chat or any application that you're running is loaded via pace into these different um, applications, right? So each of these applications, though, are have their own class loader. So they're not using the system default class loader, because if we did that, we wouldn't be able to find the classes that we need to load, right? So if I just got parameter sweep, there's no way that the system class loader can know about that jar, right? Because it couldn't have been in the context before I got it. So that's why we do this URL class loader, where we actually add new jars into the path and then load classes from them. And we actually even load them without even knowing beforehand what their names are, right? So we do all that, but the problem is this happens okay? If we think of okay, if this is Pace, right? It actually has the app launcher, right, off its main, and then the app launcher actually maintains app, actually maintains the app threads running here, right? And then off of this, we also have, actually, funny enough, it's not off of there, because we load Juxta as a regular app, okay? So let's say in this app, I load parameter sweep. What will end up happening is the class loader, the URL class loader, will grab parameter sweep, right, and load it. So that's the class loader used there. Well, over here, Juxta has its own URL class loader, right, which launches the networking subsystem, right? So when I send remote events, they come up through the main PACE event queue, right? I emit a remote event. This detects that it's remotable, it goes down to PACE, and then PACE will see who can handle remotable signals, right? And then this guy will get it, okay? He actually has a bunch of groups running here, which correspond to the groups that are the apps, okay? So one of these groups will grab it and send the remote signal out, right? Now that remote signal will get somewhere, and something will happen, and then usually another signal will come back, okay? So another signal comes in, right? On this other signal, there's data, and that data is marshaled, right? It's serialized. Serialized, put into a byte array, and then sent. So we get a byte array back. Okay, that byte array has class information at the head of it, which says, I'm of this type. And if you get that class, I can unserialize using its methods, and then I'll be an object, right? But the problem is this. This will be some sort of parameter sweep dot something, like a work unit, or a result unit, or something to that effect, right? Well, this class loader has never seen that, and it's never seen that jar, right? So what I'm doing now to unmarshal is I actually have Juxta in here in the receiver. It actually goes and grabs the class loader from the corresponding app, and then it will use that class loader to unmarshal, the information. Then that will get it the signal, right? The signal into a form that it has actual data, the correct data object, not byte information. And then once it sees that, it actually can hop and jump right to that app queue's event queue. So in other words, it can just directly message that app queue's event queue. So then when it gets in here, it can get casted and stuff like that and then be used. Okay? So what ended up happening is I'm realizing more and more that our group tree needs to really have a sufficient amount of information to kind of pass things back and forth. So what I ended up doing was, in the application objects, they actually hold on to their class loader that they use. So they'll keep that with them, right? They'll keep their class loader so that you can use it later. And then that, in turn, is in the group object. So right now, the group objects tie these things together, right? So it'll have basically an app and a net, right? And then this is an application object, okay? And this net is a generic object which can end up being casted to a peer group. Okay? So this way, these two can kind of talk to each other, but it's more the Juxta, the networking subsystem knows this is an application. But we need to make sure is that the application does not know that this is Juxta. Right? It just knows that it's some sort of network object. Okay? What we might end up doing is, I don't know, we might make an interface of some sort for those Juxta groups that get spawned, because Juxta essentially builds the same group tree itself, because it understands it in terms of peer groups, right? And then this understands it in terms of application scopes, like who's working on this app. So we need some way to equate those two. So I don't know if it's quite as important as of the group understanding that the peer group's associated with. I think it's more the peer group latching onto the app. So we might be able to take that piece out, but I'm not sure. Right now, a lot of group is being used in horrible, horrible ways of kind of ways of messaging between the network and the application, which shouldn't be used. They should only go one way. They should only go from the network to the app, because the app is the only thing that we know what the object is. It's an application, so we can kind of talk to it. Whereas the only reason I have this casted object here, and the only reason it's safe, is because the only thing that will reference that is internally. Okay, and that's what we want to try and do with these objects, is make sure that if you're going to cast it, you already know what's in it because you put it there. So this guy can cast this object to peer group whenever it wants internally. But I'm afraid that that's going to get bad once we get to the point where if you have different networks and stuff like that, how that's going to work. Okay, but that's the basic idea of how some of the messaging goes. You'll notice I've added a remote signal, which only slightly changes how the regular events work. I added a few different little fields. Let me take a look at those. First of all, are there questions on that? How those are tied together? Okay, so a remotable event, I've changed slightly from the regular event. What I've added are a few fields. Network source and network destination. Again, notice these are objects, which is, again, okay because the only thing that's actually going to interact with those objects as their actual class are the same network subsystem that created them. Okay, so those source and destinations, we can use those in some way, but I don't know. Right now I'm not really using them because I just set up broadcasting and that's it. So broadcasting is simple. Whichever group is going to send it has its destination. It's the whole group. And through a system of just, wanting the signal and not wanting the signal, you can communicate just with broadcast, which is simple. But this will eventually be sources and destinations. Now, the reason that we still have that, even though like the app, for example, can't have any use of the actual object, it does understand them as fields in this remotable event. So if you get an event, you can actually flip it and go back, like say now the source is the destination and the destination is the source without knowing what the object is. So if you get something, you can reply directly to the person who asked you without even knowing what kind of entity that is, right? Just it being a generic object, because you're not going to cast it, right? You're just going to store it in this other place. You're going to send it over there, and then the networking subsystem can cast it and use it. I put in a couple enumerations of like these different styles. We may or may not want to make different objects for some of these styles or purposes, but right now this seems sufficient because I think, like for example, Juxta supports a lot more efficient querying capabilities where you can just do simple broadcast queries and get results back without as much, but you can't really put as much payload and stuff in them. So we might want to be able to do that, but we might want to create a separate query object just because, like a subclass of remotable event, mainly because a query can only hold so much. So we could restrict use of the query object to only being able to put like maybe simple data types or something like that in there. Okay, or something that can be turned into the XML file that they're expecting. A couple things in the superclass, I actually had, and I don't know if this is the best way to do it, but I added a remotable flag. That seemed like the easiest way to check if something's remotable. I can't really check if it's a remotable event because, I don't know, down the line if we create other subclasses and stuff, I guess we can just check if it's a remotable type, and remotable has to be the root of all remotable events. But for now, I just made it a flag, and remotable event sets itself to remotable. You just set the remotable event to remotable. I think I have in the constructor. Yeah, I default to setting the remotable to true. A couple other pieces are remote name. So this idea is that if you're the networking subsystem and you're about to emit this remotable event, on the other side, this is what kind of event you should create, right? Because we can't have it be the same name when it gets to the other side. Why is that? Because we know we can't process that event because that's how we got to the networking subsystem to begin with. In other words, if the application emitted this event, the only way it got to the remote to the networking subsystem is that it couldn't handle it itself. Because if it could handle it itself, it would remain in the scope of the application. So we need to have this mechanism for changing name, and that's how I did that. Just setting it as a field also seemed all right because if you're in the application, writing the application, you know what signals your application can receive, so you know what to set this that you have to set this remotable name to something you can receive. So it should be the application's responsibility to do this transition. And in the remotable event, I provide a basic automatic mechanism. If you don't set the remote name, it'll change it to .remote. So whatever signal you send out, it'll be that signal .remote. So I want work unit .remote will be what it ends up being on the other side. So your application, if it sends out I want work unit, it needs to be sure to be able to receive I want work unit .remote. And that's about it in there. Okay, so now the networking subsystem. Okay, so the basic idea behind the networking subsystem is first we have this Juxta launcher. And in the initial design, I realized that it wasn't using the power of our signaling infrastructure. It was doing a lot of stuff where it was just asking and getting a reply back and doing more and stuff. It's not just doing a job signaling. Okay, so what I did was I revamped it so it can just do a job and signal. So you'll see that Juxta launcher is very simple. All it does is it creates the root world group. So it joins basically the Juxta world group. Okay, and then it will ask, and then from there it'll say, all right, paste peer group, I've created the world group. I need you to handle the pace world group. Okay, so then we go to the pace world group, the pace peer group. Okay, and the signal that was emitted is join pace. However you want to do that. So join pace will slot to slot find pace. Okay. I don't know. You may or may not want to adopt this convention. I started naming everything that was a slot. I started prefixing it with slot, mainly because in the IDE it puts them next to each other, which is useful because I've started using the IDE more, especially since we're all working on this. I find that where I expect to find things isn't necessarily where I'm going to find them. So I've been using the IDE a little bit to navigate through. So we have slot find pace, right? Slot find pace, and I outlined this in the comments, is we should first, okay, we should first check the cache copy, and I realized that what I said before was wrong. You should go in the order of cached, remote, then create. Okay, and the reason it was screwing up on me so much before was that not that I was going remote, then cache, then create. It was the fact that everything else was kind of in a half-broken state. So your cache wasn't reliable, your remote wasn't reliable. So it ended up being. I mean, it'll still work the other way. The only reason this is better is because it's faster. So if you can rely on your cache, if your cache is useful, and you know your cache is useful, then you can immediately return from the local lookup and start working instead of waiting for the timeout of remote. So the idea here is you look for a cached copy of the peer group. If it can't find that, it will send a remote advertisement out. And then after a timeout of the remote advertisement, it'll create a new peer group. Okay? So what we do here is find pace first, right? I'll try to find it. I go through the local advertisements and see if I have a cached group named, the pace. Okay? I'll get some responses. If I get a response, that means I do have a cached copy of something that matches name named paste group. Okay, so I will join it. Okay.
Yeah, that's another question I asked. Like if I'm looking for and I say paste group and no wild cards, then I shouldn't have to go through the
You
enumeration.
shouldn't have to enumerate because one of those is paste group. Now, whether it's correct or not, we would have to be for additional error checking. You know, but if it's named paste group and that's what we know that we want to name it, we could we can rely on the fact that any one that comes back, you should get it. So
Okay, so
once this thing, if this thing works, you will only get one reply. But you might get multiple replies if there was weird combinations of somebody having a different version of the paste group, and but because of this, there should be little chance of you joining that group that you don't understand. So, um, I don't know. Depending on how Juxta does its IDing and stuff like that, I don't know, but it seems to work. I don't know what's going to happen when we get into more peers interacting with each other where they all might have a different idea of what the root paste group looks like. We might need to do more checking here. Um, but even then, how do you know which one's the best? So you don't, right? One thing might be join all of them and see how big they are. I don't know. But so we check to see if we found the local one, a local cache copy. If we don't, what do we need to do? Well, if we don't find a local one, we know we can't do anything now. So I have two options from here. I can either create one or I can check for a remote one. And I don't want to create one until I've given it enough time to check for the remote one. So what I do is I ask for the remote advertisements. I set this last field in get remote advertisement is who's the listener. So I set myself to the listener. So I say, go get the remote advertisements and notify me if you find one. Done. Fired that's asynchronous. It's non-blocking. I call it and it fires and forgets. So I fire that. Um, if Okay, so now what I do is I actually am going to emit another event, which is give this some time. So you'll notice I added on a nifty little feature of events saying that you can set them for a delay before they fire. This may or may not be the best way. I found it to be good for stuff like this timeout. And I also found it good for things like polling. Okay? So, I don't know, and it's also not a busy wait. So when you're waiting for something, if there's nothing else to do, it'll just pause for that amount of time until it fires. So if so what we do is we put that timer out there and then we're done. And then we're done with the method. So what's happening now is two asynchronous things are happening. One is a timer's ticking, right? And the other thing is that the network is listening. One of these will come back. Okay? Let's look at the one that we know a little better because we wrote it, which is we get a native event. We get a native paste event. We get remote paste timeout, right? So if I go back up here, remote paste timeout slots to create paste. Okay? So what I will do is I have a flag here so that I can track something inside this synchronized block. I go into the synchronized block saying, so I want to do all this atomically, this whole block. So the reason I want to do this atomically is that I want to check if it's null, but while I'm creating the group to set it, I don't want anybody else to check it to see if it's null or not and set it, right? Because if I'm on this step and somebody else checks if it's null, it's still null. So they could start creating it, and then one of us would get clobbered. So the idea is until I'm done creating it, no one can check the value of this peer group. Okay? So I synchronize on peer group info. I check to see if it's null. It's not null. I mean, it is null, right? Because nothing's come back. Our timeout is gone and nothing has altered the peer group. So what I do is I generate a new peer group ID. And this is one way I thought to make it a little bit more consistent is I generate the actual ID. And I generate the ID by giving the world group of that I'm a member of and then a seed. So the seed is a constant. So as long as we use the same seed, you have the same view of what the paste group is.
I saw that.
Yeah, so the seed is actually a byte array, I think. Yeah. So our seed is 49991337. Yeah. All right, because we got the elite hacks. Okay, so we're back in slot create network. Okay, so we create the seeded ID. I mean, we seed the ID and create it. Okay, then what we do is we create a peer group. Its root is the world peer group. Its ID is this one we've generated. Name is pace group, and its description is pace group description. So at this point, we've created pace. Okay, so I set the state to loaded because there's no corresponding app that I need to load. This group is ready. The root group is ready. Okay. Now this create peer group, let's take a look at that. This is mostly from the original code that we had. No, wait. Okay, yeah. So this is generic juxta code for the most part. Okay, you need this advertisement thing because I think that's the basics of the advertisement that says it's a peer group. So I don't know why that's not included in the create peer group, but this is so I think you can customize this, like associated apps with it and stuff like that. Like normally it's just the juxta shell and I don't know, but this is just the generic implementation advertisement for the group. You add that along with your peer ID, your name and description, and then you create it. Now this publish group, I don't know if that's necessary or not.
It only if you publish the advertisement, you don't have to publish the group.
Right, but we haven't published the advertisement anywhere.
Then all it does is
All this does is yeah, is it takes the current group and then goes to the parent and publishes it. Now, I don't know. It seems to be slow sometimes, but I don't know. I don't know if it does it immediately or what. But um, so this publish will get all this info from the new group and then put it in. I don't know if new group does any auto publishing or not. Is really what I was wondering, but I don't think it does. So I do this publish group. Um, I don't know if this is any. I don't know if this does the remote publish as well as local publish or not, because there's two different styles of publishing ads. Is you put it in your own cache so that if anybody queries you, you can show them. There's another thing where you can actually actively send it out to the peers, to your remote peers, and optionally even not store it yourself. In other words, just publish it out there. Um, I don't know, but I'm just using their generic publish group, and then so that gets published. So now we have Pace out there, um, and then we're done. So what I do is, if I went through this block, that means that I ran and I'm the one who set the root Pace group. In other words, I found this to be null, and so I set it. Okay. Then I call this method. Notice I needed that flag. I need the flag because use I can't use whether or not it's null. Because if it wasn't null, then I need, and also I can't use any variables in here because it's in a block. So I can't. So I just basically created a flag that says if I pass through this block, I'm good to go. And I mean, the other tricky part is I can't have this inside because I actually go out to another method that this starts getting out there. So it's not. I can't remain in a synchronized block or else it'll probably go screwy. I'm not sure, but so I just put it outside. I check if it's null. Notice I don't have to synchronize this because I'm just checking if it's null. I'm not setting it. The only time you need to do that synchronization is if you're kind of reading and writing to the same data. So I check if it's null. If it's not null, then I will do this, which is initializing stuff for that group, the pace group, and then also sending out an update so that user interfaces are welcome to use this information to know that a pace group is now available. Okay. Now, what was the other option of something happening? And this was if we get back that delayed signal. If we got back this delayed signal, what was the other thing that could happen?
you find the group.
Yeah, so we get a remote advertisement back. This is not done through paste slots and signals, right? This is done through Juxta. So by adding this as a listener, you'll notice that this object implements discovery listener. Implementing discovery listener means you have to implement a method called discovery event. This is just like in Swing, right? If you implement discovery event, that means this can happen. We may or may not want to. I don't know if we want to switch to this style. I don't know, like where we just implement interfaces for every single kind of slot and signal. I just don't know if that's worth it, just from the standpoint that I think they need to be strings, because apps creating custom signals and whatnot, we don't want paste app to know about those interfaces. So I think the slots and signals is fine how it is. But discovery event. This is called if you get a reply back to that query that you sent out with the get remote advertisements. Okay, remote advertisement comes in. I can check it, and if I get one, I know that it's a paste group because my query said only get things that are paste groups. Okay, I'll get the advertisement. I'll do my set to false, go through the same type of block where I join the group, right? Join the peer group, set it, and then I set my state to loaded, set true, and then I get out here, and then this network group is the same thing that we saw before, right? It initializes the rest of the other, it sends out a signal saying, hey, we're ready, we have a paste group, and then it also sends it out to the user interface so that it can update itself. Now, this join peer group is, again, generic code. Join peer group is generic code for joining peer group. We create a group based on the advertisement that we got back. This new group is not saying create a new group. It's saying I have a view of a group that I got because I got an advertisement. In other words, someone told me about a group. Make a local group for me so I can have a view of it. Okay, so now we have a local view of the group, and then we join it using this. Right now, it's just a null authentication mechanism where we don't have any authentication, but you could optionally make this authentication eventually. Okay, so now we've joined. So notice in either case, the final result is this, which is two signals, right? So by the end of all this, two signals should come out: init and network group. And that is either through finding a local copy, right? Creating a new group, or finding a remote group.
Question. Do you have a way, you didn't before, of creating a non-paste group?
No.
Okay, that's it.
But where would you wire that in?
I was thinking
You'd wire it in
non-paste
here.
group.
Wired in at Juxta Launcher, all you do is emit join files or whatever. You see what I'm saying? So you'd be kind of a separate branch that we could look at. And that way you could have file groups, you could have subgroups and things like that. So you'd be kind of like another.
Well, that's what I was going to do, but I mean, is there like a generic, we don't have it anywhere where just the code created?
No. What you're going to end up doing is you're going to create something that looks like, kind of like this, and then we're going to extract a superclass from that and make that the superclass and put them together. Right? So, I mean,
What is that? I can't see.
this one?
Yeah, it's a paste group.
This is paste peer group. So that's the root of it. Now, so you'll do cut and paste subclassing, and then we can extract the superclass from that, so we'll have a general way of doing this. So you're going to be much the same way, though, as far as files and things. Now, really we just have to worry about how we're going to store them and stuff like that, and handling clashes of different files, and what are we going to name files when they're on that network.
That was one of the
Yeah.
things I ran into last night.
Yeah.
Like, if I get a duplicate file.
Right, and should I replace this or what, or should we have like these IDs? We almost can't replace or delete any files because if something's using it or whatever. I mean, we can remove them locally.
Right now, I just ignore it.
Yeah, like if you get a duplicate, yeah. So we'll have to find some way to ID these things. We'll probably do something along the lines of creating like generating a UUID or whatever, and then some unique identifier, and then using it like that. Now, and that's the thing, we're going to have to do some sort of, hey, I'm looking for parameter sweep.jar, and then the file manager has to make a decision. I think I'll give him this one. This one looks like it's the best one. Or the other thing is that if we can really get the jar, like the one we need, like if we're joining a network, we can ask what jar to use and get it. But we need some sort of ID for it, and I don't know. We'll have to coordinate that between these two different areas. Okay. Yeah.
When I was going to send, well, my thought for sending the file back to the person, like I just created a pipe, because I guess because you look like you did some Jixon stuff. So I was asking you, I was creating a pipe with the file name, and then what I was thinking was, it's just a pipe to request, like a request pipe. They send the request, and then you say, okay, they send you, what I was doing was sending I think the UUID, that ID, and then they create a peer ID from that, and then send it back to your input pipe waiting for a file.
So they directly connect to you and send it to you?
Yeah,
Now, I don't know. You might want to look into their query. They have like a thing called, I don't know, it has to do with their queries. It's just a lighter weight version of the pipes, I think.
Okay, that's probably what I need for that first.
It's something, it's not the discovery service, it's like a resolver service or something like that. I think the resolver service has a query response mechanism where you can do something along the lines of who has this file. Somebody can answer either by answering or start sending the file. So you use that to kind of query and then use, I don't know, whether it's pipes or it's there's sockets or whatever. You use one of those mechanisms to actually transfer the file. I think the hardest part is really once you get the data sending back and forth. The hardest part is going to be deciding how to identify them, where to put them, and stuff like that. Okay, but okay, so paste peer group. We have two signals that can come out, right? Init and network root. Well, network root goes to the GUI. Init comes back to the rest. So we go to where is it? Paste discover. Okay? Paste discover slots init. Okay? And it slots init by, first of all, it quits any previous one that it might have been in. And then it will set the paste group. It'll get the peer group info. Peer group info, by the way, is just kind of, in the GUI, I created like a model, a swing model that kind of used the group tree as its, like to show us a tree in Swing, what I did was I used their model interface and wrapped around our tree model of the groups, right? I'm doing the same thing kind of here. I wrapped the group information in juxta group information, and then I can use the underlying tree to see this subgroup of that that network of this, the subnetwork of this network. In other words, the peer group info is in this, the peer group itself, right? The object representing the juxta peer group is in this peer group info. But how it's connected to the others is still contained within the group model, right? The paste group model. Okay? So I slot init. I create my wrapper object of the peer group info. Or actually, I get the wrapper object from peer group, from this paste peer group object. And then what I do is I get the discovery service of that peer group, and then I add myself, this object, this paste discover, as a listener of that discovery service. Okay? What this means is that any discovery events that happen, I can respond to them. Anything that happens within that group. Okay? And then I emit paste discover. Okay? Paste discover is a loop. And paste discover is slotted to slot discover. Slot discover will periodically get remote advertisements of different groups that are part of this, that are subgroups of this group. Okay? And then I set a poll delay, and then I emit it again. This ends up being a heartbeat for the whole Juxta subsystem. I don't know if there's a better way that we should be doing this. Okay, but what I'm doing is just basically creating a loop. This starts the loop, this emit paste discover, and then this loops with itself because it just keeps emitting paste discover as it goes on. And if we ever quit, it'll set this to null and this guy won't loop anymore. But apparently right now we can't quit because Reed broke my quit signal. He's putting in some of the state saving stuff, but in the process, the quit signal is destroyed. So we just quit the old-fashioned way, which is Alt Q and have it just kill everything. All right, so um, you got to break a few eggs to make the omelet. So before getting to the point where we have state saving, so that our state is always saved, no state gets saved. So even state, even the state cleanup that we had before is now gone because of Reed. But anyway, so we got this loop that goes on. This is so basically there's a loop running here of the discoverer. Okay, this is a loop that keeps running. It's a poll, right? Well, what will happen? Well, notice I did a get remote advertisements, and I already have a listener added, which is myself. So, anytime a discovery event happens, we go through this. Okay. This is the mechanism which creates the children of the PACE group. This will eventually have to go down to them having their own discoverer. Each of the children should have their own discoverer that's looking for additional subgroups of that PACE group, right? So if I have an application group, eventually we might want the capability of an application group having subgroups, maybe sub-work groups like you work on pre-processing data, you work on calculating, you work on post-processing data. So you might be able to create subgroups where peers can join into the subgroups rather than the main group. But we'll have to decide that once we get to more complex apps. So if I get a response, I get the advertisements. The first thing I do is I collect what subgroups I already have. Okay, this linked list holds all the peer group IDs of all the children that I already have. I do this, and then I loop through the advertisements I got, and I check if if there are any in there that I don't have. If I don't have one, I go through the child group generation process, which is I will create a new PACE group model group. Okay, I'll set its name to whatever the PACE group name is. It's a net, it's an app. Because again, these are all the applications that are running that I've discovered. It's a net, it's an app. Its state is discovered. It's app config. This is the kludge right now, which is just storing the jar's name and the description. Okay, this should actually be an object, a config object that we want to pass to these other to a new instance of the app. So it should be a config object that will tell us what jar to use as well as our initialization parameters. Okay, and this may need to be some sort of what this might be is we don't put any app config in there. It's just when we join the group that we actually go query for it and get it. But right now, I'm just setting the app config to this. This is a kludge. Oh, and I have it in twice. Awesome. But so both of these are a kludge because they're the same statement. But this is the one that has the comment saying it's a kludge. All right. And then we add the child to this group with this group as a parent. Okay. And then we wrap it with a new peer group info object so that we have understanding of not only the PACE group model, but also the juxta model on top of it. We add this to the list of advertisements that we already have because we might be looping through here. And if we find two versions of the advertisement, we don't want to add them both. Okay? So after we do that, we do a network update. And a network update is is a signal that goes to the GUI. So the GUI can say, "Oh, this particular group has updated. I should reflect whatever I need to," and that comes in the form of new applications popping up in the tree when they're discovered. Okay. So now, what we have now are we have peer groups for any apps that we find. Okay? And these happen anytime we discover apps through this polling or we get signaled, like even if we don't poll, if somebody publishes a group, it can actually hit our discovery listeners still, because we're not listening because every time we do the get remote advertisements we listen. We're just listening in general. And if we find one, either through us querying and somebody responding or somebody just telling us, we'll get these new groups to come up. Okay? So now we each have a peer group. Okay? Now again, I think we need to take this mechanism and also have them have their own discovery system that runs. Right? But I mean, we don't have a use for that yet, so I didn't put it in. Now, actually, these are just discovered, right? We're not actually part of the group. What ends up happening is if you want to join the group, you actually signal using the user interface. Okay, so in our case, you go in the tree, you highlight the group, and then you hit the join button. Well, the join is slotted using this, join network. Okay? You will get a signal. In that signal is a group. Right? So what you will do is you want to join the peer group that represents this group. Well, the group itself we only know about because we discovered it, and we put kind of like a phantom group in there that is just discovered. Okay? But we want to load it. So what we do is we go to the parent and we get the parent's peer group so that we can do stuff like join the group. We get the peer group info of this group, and then we will join we get this group from the group model, right? We want to join it. So what we need to do is tell the parent we want to join its subgroup, this, okay? So what we end up doing is we do this join peer group, passing it the parent as well as the advertisement of this particular group. So it will go and run join peer group, which is go to the parent, create a new group using this advertisement. So what we've done is we actually created this group. We've joined that group, and now this is a full-blown group now, not just a discovery of the advertisement. So the initial pass of the discoverer was find advertisements. And then when the GUI tells, or the user interface in some way tells us join this group, then we actually create a paste group. Okay? Once we've joined that group, though, we actually have some additional things we need to do, and that is load the application. So once we join it, we set our state to loaded net. In other words, the network's loaded, but we're not completely loaded because we don't have an app. And then we ask for loading the group. Loading goes to the application subsystem. So load will actually go to App Launcher. Right? And we'll go through the same process of getting the jar file, which we know because when we initially discovered the group, we got its description and put it into the description was the jar file, and we put that into our group object. Oh, actually, there it is right there. Okay? And then we're back to the same mechanism of when we were creating groups, right, of loading the application. Okay? Now the final thing is, for every time we join a group, we set up this little guy, remote signaler. Yeah. Anytime we're getting involved with a group, creating one or joining one, we also set up a corresponding remote signaler. The remote signaler is in charge of The remote signaler is in charge of doing the broadcasting and whatnot. So when we instantiate a remote signaler, we give it an event queue, which is the network's event queue, right? Ooh, you know, it'd be interesting. What if we gave it the application's event queue? That'd be neat. That'd be a way of tying them directly to the networks. In other words, you have the main pace event queue, you have the app launcher. Right now what ends up happening is the app launcher will launch like Juxta. That'll create peer groups, and they have their own event queues here. Right? So they each have an event queue. Here, we'll also create things like chat. It has an event queue. Parameter suite. Right? So these are other ones, other event queues. Well, this peer group actually ends up spawning some remote signalers, which have, actually there'll just be one for each group. They end up spawning remote signalers to handle signaling, right? It might be neat to just go ahead and have them spawn a remote signaler that's actually tied directly to the app. It would definitely be more efficient, but we don't really need efficient yet. We just need working. Okay. Well, remote signaler, okay, is created from the peer group, right? We get the peer group info of the group that we are signaling for, okay, and we get the event queue of the networking subsystem. So we're an abstract object. We just link into the event queue like any other object. We set our private peer group info to the one we were passed, okay, and we put ourselves into the peer group info that we are the signaler. Okay. So once we have the, and again, that might be a way to make it so we don't need that info, is if we tie directly into them. But anyway, then what we do is we set the pipe receiver and set pipe sender. This is spawning two other little objects. Okay. So we're the remote signaler, and then what we need is a sender and a receiver, and these are just things that can work kind of independently of us using Juxta. So we create one of each of those, and then we create slots saying that we can respond to this paste discover event. Again, this is a way just to hook into something that we know is going to poll periodically. And then we also add the slot remote, which is remote means that we've received a remotable event. Okay, how I tricked the signaling subsystem into doing remotable events is normally you have to have a slot. You have to tell your event queue that I can receive this particular signal. That way, the event queue, when it's going through its stuff, it'll say, "Oh, can I? Can you handle this? Who can? Or actually, it says who can handle this." It looks up in its signal table. It says these are the objects that can handle this. Well, the problem with remote signaling is you can handle any remotable signal. Right? So you can't say, hey, can you handle I want work unit dot remote? Because the network doesn't know about that signal. It just knows it can handle any remotable signal. So what I do is I have remotable signals fit in a slot called remote. So anything that can receive remote can send a remotable signal. Okay? So I slot that to remote signal. So creating these two objects, pipe receiver, pipe sender. Pipe receiver, pipe sender. Well, pipe receiver, okay, will actually join any input pipes it finds. Okay? Pipe sender will create an output broadcast pipe. So if all the little participants on this application, all of them are creating pipe senders when they come up, well, we should have a bunch of pipe receivers available when we come up, right? Because we'll see everybody who's published their output pipes. So I tried to do it with just one pipe for everybody. I don't know if that's possible. I think pipes can only have one output. So basically we have to create a gajillion pipes for each of the peers. And I don't know if there's a better way to do that. We'll see if there's a better way to do it in Juxta. But for now, this works. It just doesn't scale because if we have a bunch of things, if we have 20 nodes, we have to join 20 different pipes to get any of their broadcasts. So I don't know what the better way to do that is. I don't know if it's better to just sit there and not join to any pipes and then discover a pipe when somebody wants to talk and then, I don't know. I don't know if it's any different. But we get the local advertisements. If we don't find a local advertisement, we add a discovery listener. Adding a discovery listener will make it so that anytime somebody lets us know that they have a new pipe, we can join it. Notice there is no, so this right here is so that we'll listen for any new pipes in this subgroup, but there's also, where is it? Didn't we respond to, oh, we actually don't do the polling. The pipe receiver doesn't do the polling. We actually poll down here in remote signaler. We actually slot paste discover here to periodically ask for more pipes that we've seen. Okay, so this discovery event will then be listening. Every time we get a discovery event, we just add ourselves to the input pipes that it's discovered remotely. Okay, and that's it. Okay, the only other thing that can happen in pipe receiver is if we actually receive a message, but we need to have another node send us a message in order to receive one. So pipe sender is the other thing that spawned. Pipe sender works a little differently in that we will go through, we will check to see if, what is this? Pipe sender, checking output piped advertisements. Okay, so what we will do is search for a specific pipe, and that pipe is the broadcast name constant plus our peer ID. Okay, and we will look for that in our local cache. Okay, if we find one, we'll store that advertisement so that, because that's the advertisement we're going to use to broadcast. Okay, and we will publish that advertisement, letting people know this is how if you want to listen to me, you have to subscribe to this pipe. Okay, notice we don't go searching for remote pipes or anything like that, right? We check our local ones for a cache. If we don't have one in the cache, then we create a new one. We're the output. We don't want to look somewhere else to find out if somebody has our output. Once we've created that, we're now capable of sending things over that pipe. So, whenever we get a remote signal, we slot to remote signal, and what it will do is it will broadcast. So when we broadcast, what we do is we use the pipe sender to send. The pipe sender send routine is this. We create an output pipe using the advertisement that we either created or found in our cache before, and pipe sender, this pipe sender is the listener. Well, once that pipe is established, the output pipe event fires whenever anybody is going to listen. Yeah.
You can use the same advertisement to send and receive. You can go both ways with that pipe.
Who can? This guy?
Either one. Anybody. Well, if it's a...
But I think it's, I mean, it's not, can you have many outputters? In other words, I was running into trouble when I tried to make it like that, where I have one advertisement, which is basically the global group. When I tried to make it like this, where you have peers all in this one paste group, I tried to make one advertisement that they could all use where they could both input output to the same advertisement.
No one has
I didn't seem to have much success. I mean, they didn't seem to be reading it. If I can do that, I can just wipe out all the individuals. But right now, how I ended up having to do it was basically you can go like that, and then and I just do fully connected. Because I don't know if that was just a limitation that I couldn't have multiple outputters on the same pipe. Because see, you can do that. You can use the same advertisement, but everybody has to resubscribe every time. That if you're going to send, they need to be listening. I don't know. I don't know if that's a limitation of Jux. I might, I might want to try that, like revamping it so that we all use the same ad, which would be easier because that's only one thing to maintain for the whole group. But either way, you join the pipe, and by joining the pipe, how I think the pipe system works is you don't actively send it. Okay? I don't know if you necessarily put it on the wire. Well, you can put it on the wire. Like you can use multicast where you broadcast. But the other thing is that if other people were listening to your output pipe, right? If they were listening to you, you can't actively go through everybody that might have been subscribing to you and send them because you wouldn't know, right? So what ends up happening is you kind of create an object, this pipe sender, right, sitting here with a signal. Okay? And any time somebody who's subscribing to your pipe, okay, if you multicast, you multicast. So you send it out to everybody. But there are some that might be further away that you don't multicast to, right? So this guy will say, oh, I'm subscribed to your pipe. What it will do is it'll say, hey, I'm subscribed to your pipe. Do you have anything to tell me? And then it will go get the signal and send it. So in other words, it kind of sits there in kind of this buffer, and then anybody who talks to it, it'll send it. That's why it's an event. See, that's why this is asynchronous. That's why we actually have to set up the object. We create the pipe, and then we create a pipe messenger listener on that pipe. Because what you end up doing is it just sits in there and sends. So what will end up happening is as this signal changes, there's a couple things that happen. One is this signal is always available, so if somebody wants to come like late to the party, they didn't get it in the multicast and they came late and asked, it'll still be there. So you don't have to be there exactly when the message is sent. The other thing is that if it changes, some people might not have gotten the last signal because it's unreliable messaging. But I think that's how it works, because the other way isn't nearly as scalable. If you have 100 subscribers, the idea of you having to actively send to 100 subscribers, like I don't think you maintain the subscriber list. They're responsible for maintaining their subscription to it. So that was a weird thing about this sending and receiving. Now you can do a synchronous send where you actually do an actual send operation right here in the code. But if you do that, you have to have a timeout, and it will just sit there for a little bit. I think it just creates it dynamically for a little bit, and then I don't know if the send operation immediately returns or if it blocks. So I decided to use this. What's that? I'm in pipe sender. Okay. Now, if you send to this pipe, notice what I'm doing here. I'm creating a message. There's 3 different message elements. There's the name, or 4. The name, the source, the type, and if the type is not void, it will also add in a data message element, which is what? It is the serialized byte array of the data payload. Pipe receiver will fire the event, pipe message event, every time it receives something. It'll get it. It'll make sure that this isn't coming from itself. If it's not coming from itself, actually this checking to see if it comes from itself is not necessary at this point. I had that from some old code. I don't think it's necessary because you'll never subscribe to your own output pipe. But if we can make it so that it goes to just one pipe, then we actually need this to be put back in. Then what we'll do is we'll generate a new local remotable event, and we'll fill it with the message from the pipe. Now, if we fill it from the message from the pipe, we set the name of the signal to the name tag that we got from the pipe. We set the type from the type tag we got from the pipe. We check if it's void. If it's not void, we unmarshal, and set the data. Create a new event. Notice I set the event not to not be remotable. Why do I do that? Well, because if I send this back down the event chain, the event queue chain, what will end up happening is first of all, I will be able to handle it if I emit that, right? If I emit that to my event queue, I'll be able to handle it because it's remotable. So if I set it to not remotable, it'll get out here and then walk down the chain back to the app. No, I emit it directly to the app. I think. This was old. I don't need this anymore because before I was emitting to the main event queue. Actually, don't have to set it to not remotable. Okay, so I can leave that remotable because I actually go get the app object and have the app object catch it directly. How can I get the app object? Well, because I have a view of the group which has the associated application information in it. Okay, so again, I'm maintaining the model so that I can interact with other parts that are subscribing kind of to the same model. That's remote signaling. So what do we need? We need serialization to work. Okay, now you have something to work with that you can see serialization in play. The first thing you guys need to do is go through. Okay, so here, now it's official. I created a working app with the chat program. I'm out. You guys are on your own with Parameter Sweep. You guys need to make Parameter Sweep work now. Okay? You need to add in the file managing capabilities so that you can transfer the jars around so that a fresh pace client should be able to load, subscribe to a group, and start running the app. Right now, we're cheating, right? Because we're loading a pace client that already has all the jar files, and then if I find like a chat app, I can just load my local copy of the chat jar, right? So you guys are on your own. Parameter Sweep. You need to make Parameter Sweep work, and you need it to be distributed. Okay? I'm going to work on something else. Not too slow for me. So I'm gonna go work on a clustering application. But now that I have at least, I need to go back and tag the pace infrastructure with a tag before y'all's brokes it, right? So I'm gonna tag it with something where everything works, and that's what I'm gonna work off of until you guys get all your stuff, settled down as far as how you want to do it. So you guys need to write Parameter Sweep. Okay, I'm not going to touch Parameter Sweep from here on out. Okay, I know that objects can signal each other and pass each other objects, and I know that they all run asynchronously. That's it. It's done. There's a framework there. Okay, with those tools, you should be able to create the entire Parameter Sweep application. The only difference is that you do need some additional mechanisms for getting the jar files. Now, if you really wanted to just hack it together, you could actually use the existing mechanisms to transfer the entire jar file and put it somewhere if you want. You can just create another sub app that says, I need this jar, and that jar can actually encapsulate the whole thing into a byte array and just ship it over and have it de-encapsulated to the data and then write it to disk. That's a horrible way to do it. Okay? But it is doable. You can do it with the basics of the basic primitives you have in there are enough to actually create to do the whole thing. Okay, so that's that. How much longer do we have in the semesters?
A little bit more than halfway.
All right.
There we go.
Oh, really? I want you guys to start presenting in class. Okay? Maybe one more week of me doing something. either reporting on what you've coded or reporting on a paper. Okay? I'll give you one more week. I'll present something next week. I don't know what. It'll probably be a finished clustering app. Okay? So I'll present something next week. But the week after that and beyond, leaving y'all to your own devices is moving way too slowly. All right? The week after that, each of you is going to give a presentation for the class. All right? And that's what we're going to do. It's going to be sessions of you guys presenting what you've done or something you've found. Okay? So, from here on out, I don't care whether what you're doing is theoretical or practical, but it has to be one or the other. Either you need to be able to give me, to be honest, I want to say half an hour, but I know that's a lot of time to talk, except for people like me who talk for just hours on end without any prompting. But I'd like for what you're doing to take up half an hour. Okay? Because that an hour and a half is just kind of perfect for what we're trying to do. Right? So, whether it's you can trigger me off to start talking, or you can get other people to ask questions or whatever, or you can really present something that actually does stuff that you can talk about for a while and then discuss for a while, or the paper that you want to talk about has some interesting things in it, and you can it brings up some stuff on how you want to integrate that into place or whatever. Okay, but something shooting for taking half an hour. Okay, that's not just you doing something for half an hour. It's just taking up a half hour of our time as far as sharing something that we can really dig into and look at. And again, I don't expect it to be like me, where I sit there and can talk to you for like an hour and a half straight just about remote signaling, just walking you through remote signaling. But something to that effect, whether, again, it's creating discussion or something like that. All right, but something has to come out, and like I said, it doesn't have to be code, right? If you don't have enough coding things to do, check out one of the papers and at least bring it up and start discussing it and telling us what the paper is about and how you think it's relevant to what we're doing. So, like if you're working on the file transfer stuff and you realize, you know what, I really don't feel like writing the file transfer code today. I'm going to wait till this is done from somebody else or whatever. Then you can sit there and say, okay, which of these papers look like they're interesting to file transfer because that's what I'm working on. I'm going to go check out this paper and say, oh, okay, well, these people are discussing a technique for breaking up files and sending them like in swarms or whatever. So then you can bring that in and say, here's what's going on with this paper. These guys, did this mechanism for creating file transfers, and what they're doing here that's unique is this. And here's where I think this could fit in with PACE. We could get these peers to do this, and we can create these signals which will coordinate it and whatnot. And here's kind of the framework of how I would implement it in PACE. So once whoever I was waiting for, which got me to be reading this paper instead of coding, once they finally get done, not only can I code what I wanted to code, but I can also start adding in this new functionality from this paper. So kind of getting into that loop of running into new information and being able to see where it fits in the current framework that we're working with. Okay, so I mean, each of you kind of has you guys have each done some of your stuff as far as like the pieces that we need in here, like the state saving, the configuration mechanisms, the file stuff, but parameter sweep, you need to make it work with these mechanisms, right? So both. Not only do you need to make it work in the sense that it needs to be working in its basic form, but it also needs to exhibit these features that you guys have, whether it's changing the configuration, because right now nothing is hard-coded, which is good, so you're pretty far along as far as configuration. It needs to be able to save its state at least to some degree where you're happy with, okay, I can't really do much more than just every so often being able to save the state, but that's good enough. It's like be able to say something about how much work you lose, like if the system crashes or whatever, or you try to quit and you're not at a point where you can checkpoint, that kind of thing. the file transfers, like all those things. Be able to say something about what you can do with it. But first and foremost, parameter sweep also needs to work, right? Using these mechanisms, because that's what I want to see. Like for example, remote signaling, the basics of loading the objects and stuff like that. That does work with parameter sweep, except that doesn't even work with parameter sweep yet, because the remote signaling works. You can send remote signals, but all the objects can't be serialized. All of them aren't wired in correctly and stuff like that. So you need to kind of sit down and make sure that all the pieces of parameter sweep works. I'd recommend doing that mainly because as you develop more features, we want to start getting into the habit of these incremental revisions where every time you check in code, it's at least in a state where that code doesn't interfere with the rest of the application, and the feature might not be done, but the previous features still work. You know what I'm saying? So that will help guide you as to which parts you should fix first. So as far as like,
I didn't break anything last night.
yeah, you've been playing. See, that's the thing. No, but see, you initially checked in File Manager and it wouldn't compile.
I was in a rush.
Yeah, so you checked that in. So I tweaked it a little bit just so it would compile. But that's a good idea. You kept it in its own little sandbox and it ran on its own, right? But and I mean, like for example, the stuff that we did doesn't break anything else. It still works. It's just one of the signals doesn't emit. Like if you emitted quit, it would still work exactly how it did. Hopefully, at least in my app, it does. Parameter sweep, it might still break, but in, like chat would quit out and stuff like that. So, and for the most part, you guys have been checking in stuff that at least compiles. Maybe makes something work not how it's expected, but it still compiles and will start initially running apps. Okay. Yeah. I think we should start using. There's a thing on the wiki that has like a there's like a little like current events page, and then there's also the user talk pages. I'd like for everybody to at least, they have these watch lists you can set up, and then the watch list you can have it email you if those particular pages change. So what I'd like to start doing is I'd like for everybody to start watching current events and watching their own talk page. So basically there's a talk page which is just, internal, discussion related to you, where I can just post messages up there, or you can post messages to each other. The idea is this is current events, I'd like to say kind of what is being worked on in general, and then the talk pages for individuals, I'd like to see what tasks they're working on. Okay, and this is mainly for you guys because you guys, are going to need to coordinate to make sure that what you're doing doesn't, like, you need to know what each other's working on because it might break what you're working on. Okay, that'll keep track of those things. I've added in a few things. Also, some of these are interesting side things, like the console version of the user interface. I think that'll be helpful, especially if you have extra machines at home that you want to try doing some of the remote stuff with. A lot easier if you're doing it over like a terminal session or whatever, if you're using like a Linux box or something like that. Also, another thing I was thinking was that would be a really nifty user interface was a web interface, where you can basically hit the peer with a web browser and be able to start and stop apps. That might be an interesting quick thing. And I mean, again, these things, honestly, I want to show you the code for chat. We're doing what we're accomplishing the goal. Okay, these distributed apps are rapid development because all I did was notice, and this isn't even necessary. It's just I don't need the chat XML. The only problem is that the user interface only lets us load XML, which has the jar in it. I don't know what we want to call it, but there's this idea that in these applications, you can actually have just loading a jar. In fact, the networking subsystem and the GUI are both just loading the jar. There's no parameters or XML or anything passed to them. If you look at main in Pace, you'll notice actually just create a group, set the app config to the jar itself, and then fire it. I just basically put those in the group, and then I fire them. And that just loads them straight up. Okay? They don't need any other information because the Bootstrap module will say what other modules to load and all that stuff, and they can just fire up. So chat could actually be the same way, but since it's a dynamically loaded app and not one that's loaded directly by main, I needed to put in a dummy chat. I mean, a dummy XML, which just points to the jar. And I had to put in the parameters here because it's not error checking to see if there's an empty parameters. It actually nulls out if you don't put that in. You get a null pointer exception. So that needs to be fixed as well. But even better would be updating the user interface so that you don't have to point to an XML. You can point to an XML or a jar. If it's a jar, it'll just load it as a kind of a empty app, an app that everything's self-contained, right? Whereas the other ones, you do have to build a config object and send it to it, like parameter sweep, because it has parameters, right? So here's chat, and chat could actually even be more simple than this, but I made it more complex so I could test the serialization. Okay, so for example, I created this chat message, and this is the only reason I created this chat message structure here is because I needed an object that was outside of the scope of Pace so that I could test the marshaller. Okay, so this is just a simple object that it's a structure, right? Sender and message. That's it. Notice, nothing else. Implement serializable, done. Right? All the data pieces in it are basic data pieces. I don't have to write any additional code, and it's serializable.
What about the?
Don't need it. Default. It automatically calls default if you don't put anything in there.
Oh, I didn't know that. I thought you had to just throw it in there, even though it was.
Yeah. So this thing just, I don't know. Maybe you do it, but it serializes. You saw it, right? It actually went over the net. So implementing serializable seemed to be enough. Now I don't even this version ID. I don't that may or may not be necessary. I don't know if it defaults to something.
The way I read that it worked is that Java, if you don't put in one, Java will automatically determine one.
Right.
But sometimes you can run into issues where, like,
well, the main thing that
depending on what version of Java you're running, like, it might create a different one. So, like, I don't know if we ran our app across different versions of Java,
right,
that UID might be different and it might not load it correctly. Like, I showed my friend how to use serializable for one of his classes that he's doing something, and he said it didn't work
without that in there.
His own
because it's technically supposed to be the version as far as like if you update the object, like if you have a different version of the object where it has different fields and stuff. I thought it was just for that because the rest of it is doing by name. But yeah, so I'm just putting one in just for kicks. I consider that version 1. Okay, so that version in there. Okay, so that's just my message. And then the other thing is this is one of the most basic Swing apps. All I did was, hold on. Okay, I do have a bunch of methods, but those are implementing the signal emitter, and they're all the same. Okay, I'm actually thinking of reducing the signal emitter interface. I don't think we need quite as much as we have. What's that? Yeah, one emit. I mean, those are just convenience methods, which I think we can do away with because they are all just this emit is the only one that you really need. Yeah, right now there's each of the apps is using different versions of the emit, but see, most of that's handled in abstract module. Because these are different because we can't extend abstract module because we need to extend the app unless I wrap it with something else, which is an abstract module, which will then have the app. But I didn't want to do that. I just implemented the interface. So most of this stuff is implementing the interface, which is the same as an abstract object. Now, the only things that are different are obviously the init component, which is the GUI, but that's all done through basic, swing forms, right? So that's all kind of handled by that. The only other thing I needed to do were adding a couple slots. Right, where's slot start? Okay, which when I receive a start signal, I'll set the window to visible. This is a neat thing where I made it so that it can sit there and you can join the chat group and you don't have to do anything. But if you receive a message or you hit start, if you hit start, it'll open the window so you can type a message. But if you didn't hit start and you receive a message, it will also open the window. But also you can close the window and it will hide it. And if you ever want to get back to it, you can hit start or receive a message. So it can actually sit there while your page is sitting there and just pop up and go away whenever you want. So I added 2 slots to handle 2 signals, right? Receiving a message from the network, or starting. Okay, I'm telling the app that I can send the send signal, which I just put into the send action performed handler, right? Which is swing, which we should all know, right? I added the action performed for that button, and all it does is it grabs the text fields, fills out a remotable event, which has a payload of chat message, which was that other class, and then I emit it. If I receive one, I grab the payload out and I add it to the output text. Done. That's the chat app, right? The chat app was stuff that's already in there, right? This is all the signal receiver and signal emitter methods. That's it. The rest of this is swing and 2 events. Okay? So doing parameter sweep, oh, also Bootstrap module, nothing in it. Just load the main window. That's it. Okay. Now, take a step back. Look at parameter sweep again. Think in terms of modules and signals. Look at those boundaries of the signals. Don't worry about serializing everything right now. Find out what you need to serialize. Look at each object individual. Take a look at input. Or I wouldn't look at. Well, actually, both input factory and consolidator, those are hard. Take a look at it, and one by one, make sure that any payload that you're sending in any of those remotable events, make sure they're serializable. Just walk through them. Make sure that stuff works. Make sure that the hardest part about writing a distributed app is you need to scale your thinking. You need to think, if I were to send this out among 20 peers, how many messages would I get back? What do I need to think of, like as far as picking one of them? And both the sending and receiving are both being done on that object. So you need to think of, as a client, which of these signals do I need to make sure work in a particular way? As a server, which of these signals do I need to think work in a particular way? So for example, if I emit I want work, somebody else, I can receive I want work. That actually doesn't work. This should be I want work remote. Right? But that's why it's broken. But anyway, I want remote. I want work remote. The sender and receiver are both in the object, but you'd never be the sender and receiver at the same time, right? So you have to think of this as myself. I'm sending. I want work. That has to do with emitting. I want work. I need to make sure this particular method works correctly, which is pretty easy considering it's like 2 lines, right? And think about these dialogues that go on. If I send out who wants work, what are all the things that happen until I get back to kind of a steady point where I'm just sitting there? Okay, so keep that in mind. Make this application work. Again, I concentrate on getting back to the point where make sure the app can run locally without any other peers, and then start seeing what can happen when you add in a peer. Okay, you guys should get used to being able to run this. I have a feeling that you guys don't write code and test while you're writing the code. Okay, get very comfortable with running pace. Okay, running it, and especially running multiple copies. Here's what I can recommend to you for running multiple copies. All you need is 2 versions of basically the juxta directories to run. Oh yeah, that's right. My quit is broke. Let me alt Q. All right. I run in 2 different directories. One I run in pace, which is helpful. So I have a juxta directory in here that has all my juxta config as well as the cache manager. Okay. I also created a different directory called, very cleverly, test. Okay, and in there I have another juxta directory. So if I start pace in this directory, it will actually get juxta set up as a different peer. Okay, so if I remove that and now I run pace again, oh, if I run pace again, it will pop up with this stupid juxta configurator. That's the worst way that they just spawn swing and start doing their own thing just by using a library. It's ridiculous. So we also need to fix this so that we're not using their thing. Yeah, you want your own config to be handled in there. But anyway, so I can create, this test cloister. And then I could set up other nifty little settings if I wanted to. I haven't really played around much with these different settings, but I can create a new dude, and he'll go through and basically initialize on his own. See? So now you can have 2 versions of pace running. Okay? And then they can sit next to each other so you can test signaling between them. And right now there's enough debugging and stuff going on that it can help you check for things. Like you'll see it demarshaling and stuff like that. So you'll know when stuff's happening. The other thing is JUnits. JUnit is a testing framework. I did one thing with, I was trying it out because I was testing that DOM loader, and I wanted a good way to test it, so I decided to try out the JUnit stuff. So if I have DOM loader, right, which does something, and it's part of a bigger mechanism where there's something outside of it that you need to interact with it. One thing you can do is create a new project, create a little main app, and instantiate and do stuff. JUnit kind of builds that mechanism in where you actually, and I created this by just doing where is it? Under tools, you can't see this because it doesn't go on that screen, but under tools you can do create JUnit test. If you right click on a class, you can do tools create JUnit test, right? And that will create a file basically like this. Okay? Now that file has all these empty stubs where you can test each of the different pieces. Now, something here is broken. Yeah. So some of these have been changed. Some of the names of them have changed. Some of your things will just be basically parsing the XML and then just getting one string out. Some of them are more complex, like for example parameters. I had to actually create a config object with some pieces, and then I could compare what I got out of the DOM loader. I could compare it with this expected value. Okay, so let me fix this real quick. what did we change that to? Get private jar path. Oh, we don't. It was moved out.
Oh, there's no.
Yeah. Is there a get configuration still? There is. I'm going to regenerate this test because this is no longer good. I don't know how you can do that. Can you just refactor it by like tools? Here's how I'm going to refactor it. Delete. Delete. And then create JUnit tests. Tools. Create JUnit test. Okay. So I have this, right? So now I created, again, the basic stub test get config right here. Okay. So that's our little test, which if I get to assert true, oh, we don't have a perimeter map. Oh, fix imports. It's an awesome feature, by the way. Yeah. So all that stuff will happen, and then that will be a pass. Everything else, it initializes to fail, right? So if I want to test, for example, get XML path, no, get, where's paste? Okay, DOM loader with this argument, right? You know, obviously some of them are easy. Get XML path, right? Your expected value is what? Same, right? Set XML path. If I do that and then I set XML path to high, right? Now my expected value is high. And then so what I do is I'd assert equals, oh no, there is no test. You just need to test if it runs. If it gets through that, then this is true. So you can comment that out. This one, assert equals, will either pass or fail. Get that one out. Basically, this one will fail if an exception's thrown. Right? Test get configuration. I don't know. Anyway, so what I do now is I'd save it. What I can do is test tools or run test pace. Okay, so now I get a report of what passed and failed. Get XML pass. Why? Because we wrote it. Set XML pass. We wrote it. Config also works. These fail because they're still default. Okay. Some of the testing will be a lot more complex. Like, for example, if you test something in parameter sweep, right? You'd need to set up a basic event queue or something like that, or actually set up basic signals and send those signals in and see what happens. But in order to do that, you'll need a basic event queue that can grab, you know, events that come in. So some of that might get more complex. Okay? Yeah, you know what else? We shouldn't have just started creating objects. We should have had some design before we started writing code too. But different strokes, I guess. But so let me commit that. That's another tool that's very helpful. Is that JUnit, because what you can end up doing is test the whole package, right? And then anywhere you see red, you broke something in the interface. The idea is that JUnit exercises interfaces, and if you get any red, you've broken an interface in some way. Your app might still work if you failed, but there are cases where it will break probably. Okay? So, try doing that stuff. this case. Okay.